Hello everyone. Today let's solve the problem bus video system. Right. So this was asked in Codeforces round 481 division 3. Right. So you can just go through the question. It is very easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So just give me a second. 1 second here. So yeah. Here we are given changes in the passenger count at each bus stop, right? So again I'm telling, we are given changes in passenger count at each bus stop. So let me write here, what we are given here, we are given changes in passenger count. For the passenger count, I'll just write PC here. We are given changes in the passenger count at each bus stop. At each bus stop, right? So we must find how many valid initial passenger values. How many? So what we need to find here? How many valid initial passenger values are possible such that no time does the passenger count go below zero, right? So we have to find valid initial passenger values. Valid initial passenger values. So I'll just give here PV for the passenger values, right? Such that no time does the passenger count goes below zero. This one, passenger count goes below zero. At no time the passenger count go below zero or above capacity W or above the capacity W, right? So that's what they have given here. So if no such valid initial count exists, then we have to output 0. Then we have to output 0, right? So this is the question mainly. This is the question, right? So I'll just read the question out loud. Just listen to this. This is very easy to understand basically. We are given changes in the passenger count at each bus stop, right? So we are given changes in the passenger count at each bus stop, right? So we must find how many valid initial passenger values. We must find how many valid initial passenger values before the first stop actually are possible such that at no time does the passenger count go below zero. This one, passenger count goes below 0 or above capacity W or above capacity W. If no such valid initial count exists, then we have to output 0. If no such valid initial count exists, then we have to output 0. This one I'm speaking of, right? So this is the question. So let me come to the input part here. So here we have been given 3 and 5. We have been given between 3 and 5. So we have the values 2, 1 and minus 3. Right. So 2, 1 and minus 3. This is nothing but these are the passengers counted each bus stop. Right. So these are the passenger counted each bus stop. And we have to find the valid passenger values before the first stop which are possible such that at no time does the passenger count go below 0, right? So the output has to be 3. So the output has to be 3. Same goes with this one as well. Same goes with this one as well, and same goes with this input as well. Let's consider this input for the approach. So this is the question. We'll be discussing the approach. I'll just consider the example 1 for the approach, this one, right? Input 1 or example 1 for the approach. So you can just try it out in the same way for the input 2 or input 3 or example 2 or example 3. I insist you to try out with the example 2 or example 3 in the same way that we discussed for the example 1, that we discussed for the example 1. I insist you to try because you will get the question easily. You can just write the code in your own way, right? In your own way or in with your own intuition, right? So that's what you can do. So first, let's discuss the approach followed by the edge cases. Then let's write the code. Right. So first, let's discuss the approach followed by the edge cases and followed by the complexities, and then let's write the code. First, as usual, let's discuss the approach. So I have considered the same first example that I have given in the question here, right? So we have 3, 5. This one, the number of passengers here at each bus stop we have been given. So just give me a second here. 2, 1 minus 3. So this one. So the output that we need to get here is 3. Means the valid initial passenger values which are possible such that at no time does the passenger count goes below 0 or above capacity W is 3 here in this case, right? So 3 here in this case, minimum maximum capacity, right? So here this one will be making use of the priority queue. We'll be making use of the priority queue for this particular problem, right? So just remember this one, we'll be making use of the priority queue. We'll be making use of min priority queue as well as the max priority queue, because the passenger count should not go below zero, right? So the passenger count does not shouldn't go below zero, and also it shouldn't go above capacity W, right? So that's what they have mentioned in the question. So in this case we can make use of the priority queue, right? So this problem is designed to be solved with the priority queue or the heap, basically, right? So I hope till now everything is clear, right? Next, what shall we do? Let's move on with the step-by-step explanation, right? So here I've considered the same input here, 35213, 21 minus 3. So let's consider that the initial passengers equals x, or let's say that initial passengers equals x here, right? Let's say that initial passengers equals x. So after stop 1, it will be x plus 2, this one, x plus 2. So this is before stop 1, right? So this is before stop 1. Then these are after stop 1, right? Let's say initial passenger is x, nothing but before stop 1. So this is after stop 1, right? So this will be x plus 2 at stop 2. Stop 1 is x plus 2, this one stop 2 is x plus 2 plus 1, right? So next we have minus 3. At stop 3 it will be x plus 2 plus 1 minus 3, minus 3. So accordingly with this we will compute the prefix sum. We will compute the prefix sum, right? So here, just give me a second. Yeah, here it will be 0, 2, 3 and 0. The prefix sum changes will be 0, 2, 3, 0. That's what we got here, right? So this is fine. So the next step would be, let's keep the minimum prefix and the let's consider minimum and maximum prefix, right? So minimum prefix sum, this one from the prefix sum is 0. This will be minimum prefix. I'll just write min p, and this is maximum value, right? So this we will consider max prefix. So minimum prefix will be 0, and maximum prefix will be 3 here in this case, right? So I hope this part is completely clear, easy, right? So we have to ensure 0 is less than x plus prefix is less than x plus prefix. This is basically x plus prefix less than or equal to w, means this is the count should not go below 0. Passenger count shouldn't go below 0 and should not exceed maximum capacity, and should not exceed maximum capacity, right? Maximum capacity. So I'll just write CAP here. This is fine. And we have to make sure that the passenger count doesn't go below 0, and this one, what do we call, W is nothing but the max capacity, and it should not exceed max capacity as well. This is the bounds they have given, right? So bounds become here x greater than or equal to maximum minimum prefix, nothing but x greater than or equal to 0. X less than or equal to W, maximum prefix. This is x less than or equal to 2. X less than or equal to 2. Right here, this one, we have been given 0, this one. Accordingly with this one we have considered this one, min bounds. Min prefix is 0. Maximum prefix that we got by the calculation is 3. So accordingly with this we considered here, so x greater than or equal to min prefix, nothing but x greater than or equal to 0. X less than or equal to W minus min prefix. Here W minus min prefix, this is nothing but x less than or equal to 2. Based on this one we have considered, right? Easy to understand. So this is fine. So now x can be either 0, 1, 2, based on the this one previous step. So it has to be x greater than or equal to 0, means we can consider 0. X less than or equal to 2 means 1 and 2 comes, right? So here uh, x can be either 0, 1 and 2, means we can have three values. We can have three values. So the output that we got here is 3. So the valid passenger values here, or the output, final output here is 3, right? So the output that we got here is 3, which is equivalent to the output that they have mentioned for the example 1. The output that we got here is 3, which is equivalent to the output that they have mentioned for the mentioned in the mentioned for the example one, right? So our approach works absolutely correct in this case. As we are completely familiar with the approach, we are good to write the, I mean, sorry, yeah, as we are completely familiar with the approach, let's discuss the complexities part. So what will be the overall time complexity here? Overall time complexity would be big O of n log n. So why it is n log n, right? Because we are making use of the priority queue here, right? So inserting n elements, number of elements, inserting n elements. So just give me a second here. Inserting n elements here, inserting n elements in the priority queue will give us big of n, this one logarithmic n. So overall would be big of n log n, right? N log n, don't get confused here. So overall time complexity would be big of n log n, because inserting n elements, we are inserting n elements in the priority queues, which will lead to the time complexity big of n log n, not just log n, right? So what would be the space complexity here? The space complexity would be big of n, because we might store the prefix sum in uh, means, or we can just consider like this: we will be storing the prefix sums in two heaps, nothing but min and max priority queues, right? So two priority queues are the two heaps here. We will be storing the prefix sums in two heaps or priority queues, right? So here this one, here let's consider heaps here, so rather than the priority queue. So we are storing this thing, right? Here we are going with the basically this thing, storing part, memory part, right? So here we will be storing the prefix sums in two heaps, right? So here we are inserting elements, n elements in the priority queue, which will lead us to the this one, time complexity of big O of n log n, and the space complexity would be big O of n here. This is fine. So the time complexity and the space complexity of the code that we'll be writing in the future would be big O of n log n and big O of n. This one I'm speaking of, right? So I hope the complexities part is completely clear along with the approach. As we are completely familiar with the complexities and the approach, we are good to write the code. Let's start writing the code. Now let's start writing the code. I'll just come here. So here in this case, initially we'll be making use of the first input and the first output. So let's import the input output package. So I'll just go with java dot input output dot start. This is fine, and we have to go with the utility packages as well. So let's go with here util dot start. This is fine. So let's do one thing. Let's go with the public class main. This is fine. So within the main class, what shall we do? Let me go with main here. This is fine. So within this one, let me delete this one. So we don't need here. This is fine. So let's make use of the this one input output exception as well, or else we might get the error, right? So I'll just go with here throws input output exception. So I'll just give here input output exception. This is fine. So within the main class, first thing that we'll be doing here is let's go with the fast input output setup, right? So let's make use of the buffered reader for the fast input. So I'll just go with br here as the variable name. This will be new buffered reader, new input stream reader of this one system.in. This is fine. Same thing. Let's do with the output as well. For the output, I'll be considering this one print writer. I'll be considering print writer. So this will be pw equals, so not pw. So this will be out equals new uh, print writer. Let's consider system.out. This is fine. So the next step is we have to read the n and w. Nothing but n is nothing but the number of stops here, and w is nothing but the bus capacity. Means we have to read n, number of stops, and w, bus capacity. So let's do that now. So I'll just go with the string here. String. Let me give the variable name first line br dot this one will be read line. So this will be dot split. So let me leave the space here. This is fine. So here this will be, let me assign into uh, integer dot. So let me make use of the parse int here. So this has to be in the form of integers, right? So we are reading the number of stops and the bus capacity. Yeah, bus capacity and nothing but n and w. In the first example, we have been given 3 and 5. Nothing but number of stops would be 3 and the bus capacity would be 5. Bus capacity would be 5. So that's what they have given, 3 and 5 if you remember, right? So the number of passengers at each stop was 1, 2 and minus 3, I think, right? So the first example, the first line we are considering here, we have to read the n, nothing but the number of stops, and w, nothing but the bus capacity. That's what we are doing here. This will be parse int of, let me go with first line of 0. So let me copy the same thing for the bus capacity as well. So here and make the necessary changes here. So this would be, instead of the variable n, I'll just give w, nothing but the bus capacity here. This would be, instead of first line of 0, this would be 1. 3 and 5, we have the space. That is the reason we considered split here. This one, man, this line we are considering 3 and 5. Right, so we have the space here, so we considered split. And here one more thing, 5 is nothing but the bus capacity and 3 is nothing but the what do we call here, this one, what is this, number of stops, 3, right? Nothing but n here, right? So we are done with the input output. So let's move on with the input output setup. So let's move on with the further things. We have to read the sequence of changes in the passenger count, right? So accordingly with the question, so we have to read the, accordingly with the approach, we have to read the sequence of changes in the passenger count. So let me go with the same thing, let me copy the same thing and make the necessary changes here. So here this will be same. Instead of the first line, I'll just go with the changes here. This will be br.readline. Buffered reader itself we are making use of for the entire problem for the first input, right? br.readline remains same. Yeah, the split also remains same, right? So here this part, not the number of passengers. So here in this case, just give me a second here. So we have to read this one, right? Read the sequence of changes in the passenger count. So let me go with int a equals new int of, within the array let me give n. This is fine. So the next step would be for loop here. This will be int I equals 0, I less than m, I plus plus, right? I less than, it has to be n. So number of this thing we are considering, sequence of changes we are considering, right? So passenger count, it depends on the passenger count, this one, less than n, I plus plus. So this is fine. So here iterated value of the a would be integer dot, so let me go with the percent. This will be iterated value of the changes. So this is fine. So let's move on with the next step. Nothing but we need the prefix sum tracker, right? So we have to go with the prefix sum. If you remember this one, what do we call the approach? We got 0, 2, 3, 0, right? So we considered 0 as the min prefix and we considered this one 3 as the maximum prefix, right? So we have to go with the min and this one. We have to go with the prefix sum tracker. First, I'll just go with the variable name prefix, which is of the type long. It might consist of the longer digit. So I'll just go with the long here and initialize this one to the 0. Now we have to go with the min prefix and we have to determine min prefix and the max prefix. So let's go with the min and max priority queues, or nothing but the heaps here, right? So let's go with the min heap, nothing but the min priority queue here. This is priority queue long. So this, let me consider the variable name min queue. This will be good. So this will be new, again, priority queue. So priority queue P will be capital man. P will not be small. So this is fine here as well. This is fine. Same thing, syntax. We are done with min heap. Now we have to go with the max heap as well, right? So here we go with priority queue. Same again. So I would have copied the line. This is fine. Let me type. So this will be max queue new. This will be priority queue of this one, and max priority queue we will be going with collection dot reverse order. We'll be going in the reverse order. We are going with a max priority queue, right? So we'll be going in the reverse order. We'll be making use of collections dot reverse order here. So this will be collections dot reverse order. So this will be collections dot reverse order. So I hope this part is completely clear, man. Easy to understand, right? So let's do one thing. Now let's go with the minimum queue. Minimum queue, nothing but we have to start with the prefix 0. We have to start with the prefix 0 always, right? So let's start with the prefix 0 here. This will be minimum queue dot add of, this will be 0l. And also let's go with the maximum queue of add of this one 0l. This is fine, this is fine. So the next step would be, let me do one thing. We have to, I didn't write the for loop at all here. Oh, we don't need for loop here. What should I do, man? So here we went with the this one, minimum heap and maximum heap. This is fine, or min priority queue and max priority queue. This is fine. So here we are starting with the prefix 0. This is fine. Initially this max will be 0 or 0 as well. So L because we are going with a long here. L because we are going with a type long here. So this is fine. What we need to do next? Let's go with the iteration part. Let's try this one. Let's see whether this works. So I less than n I plus plus. So within the for loop, so we have to accumulate the, or we have to collect the this one prefix sum, right? So we can just write it in this way: prefix equals prefix plus iterated value of the a, and we have to track all the prefix sums. Means I'll just go with the minimum queue dot add of prefix, add of prefix. So this will be maximum queue dot add of this one, what do we call, prefix, right? So this is fine. So let me come out of this one entirely. Let me come out of this one entirely. Now we need the minimum prefix sum and the maximum prefix sum, right? So that will be present at the peak, and we can just make use of the operation dot peak to get the minimum and the maximum prefix sum from the min queue and maximum queue, right? So from the min queue and maximum queue, so we can just go with here to get the minimum prefix sum. I'll just go with long min sum, long minimum sum. This one will be min queue dot peak. So this is fine. Let's go with the same thing for the maximum prefix sum as well. So let me copy this one entirely. So this, let me paste this one as well. So this will be maximum sum here, this will be max q, here this will be max q. This is fine. So now we have the minimum prefix sum as well as the maximum prefix sum here, right? So let's move on with the other things here. So the next step would be we have to go with the minimum x that keeps the passengers that is greater than or equal to 0, and also maximum x that keeps passengers less than or equal to w. Nothing but we are going with the condition that the passenger count has to be shouldn't go below 0, and it should not exceed the bus capacity w as well, right? So let me write on this way. Let low equals negative min sum, and let's consider max or high here. This one high here, this will be w minus max sum. We have discussed this one on the this one, what do we call, approach, right? Whatever we discussed in the approach, exact same thing we are articulating in the form of code here, right? So this is fine. And next let's go with a simple if condition here. So when no valid exists, then we have to print 0. They have given in the question, right? This is one of the edge cases, right? When no valid exists, so then we have to this one print 0 in that case, right, in the output. So that's what they have given in the question, right? Let's make use of the simple if condition. So is uh if low is greater than high, if low is greater than high, then I'll just go with out.println of 0. This is fine. So the next step would be let's go with the total valid values of x. Let's go with the total valid values of x. Else I'll go with out.println. So this will be high minus low plus 1. Low plus 1. So if no valid exists, then we have to print 0. They have given in the question. If the valid values exist, then we have to go with the total valid values of x, right? So that's what we have done here. So we are done with the complete approach. The one thing is left, we have to flush the output, right? So we have to flush the output. Either we can go with out.flush or we can go with out.close, right? So I'll just go with, so we have made use of out.flush every time. Let's make use of out.close this time. So this would be out.close, right? So we are done with the coding part. So this is it for the code. Before checking whether this works with the different inputs, let me copy paste the signature starter template. So here, let me do one thing. Let me paste it over here. You can just ignore this one. So you can just concentrate on the this one logical part. So now as we are done with the code, let's try with the different input. So let me copy this one. We have to get the output 3, right? So let me run the code here. So we are getting the output 3, right? So this works absolutely correct. Let me go with the second input here. So let's try with the second input here. This one we have to get the output 4. Let's see. So we are getting the output 4. Let's go with the final input here. We have to get the output 2 here. Let's see. So here, let me run the code. So yeah, we are getting the output 2, right? So this works correctly for all the inputs or the examples that they have given in the question. So let me copy this one and let me paste it over here. Just give me a second. Yeah. Now, this is problem E, right? So let me select E from the drop down here. This is fine. Let me hit the submit button. So let's wait for some time. Let's wait for some time. So running on the test case one, you can clearly see here, right? So this problem involves using the min and max priority queue both in a very simple way. Just I insist you to solve this problem because you'll understand the basic concepts of priority queue, the first one and the second one, man. So this is complete, like you'll get to know the operations and how to make use of the priority queues. Very basic, right? So the simple thing about the priority queues you'll get to know from the first two problems, right? So further we can solve some complicated, I mean some little bit lengthier problems, right? So now I insist you to solve these two problems so that you get to know about the operations and other stuff of the other basic things, this one basic stuff of the priority queue. So now you can clearly see here, this one, the code got accepted. Whatever the code that we have written works absolutely correct for all the test cases, right? So now as we are done with writing the code, uh, let's ignore this part. This is fine. So whatever the code that we wrote works absolutely correct, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.